Hello and welcome to my introductory video for event-driven cloud computing. I am Cory McAn, the sole developer, tester, and documentation creator, and my mentor is Jason Detbarn of AUDIT. Allow me to define the problem that this software attempts to solve. Currently, in the IT field, there is large demand for a monitoring and alerting service that can allow admins to monitor system and security data on their clients' machines, process large amounts of data, send real-time alerts to admins regarding their clients, and do all of this without any idle servers. Here is the overview for the project plan, and the full Gantt chart is available in the Documents folder because it did not fit in the slide. Let's move on to the requirements. Here are the user stories that I implemented this semester. I will focus on the two primary stories in this introduction: consolidate audit files and run multiple tester. Here are the detailed use cases for each of these user stories. I will go over the step-by-step explanation for the primary stories in a moment. Here is the overall UML use case diagram for the project. Here you can see the use cases and their interactions. The S3 bucket runs all of the user stories, each caused by a Lambda trigger. Allow me to explain the sequence of events in the consolidation of audit files. The IT admin is on the web dashboard, and he requests a machine audit of a client machine. The request is handled by the AUDIT controller, which is involved in putting the new audit data into the S3 bucket. On a new file put, the S3 bucket triggers the Lambda function for the bucket that the file was put into. Now the Lambda function consolidate audit files runs and lists all the files in the bucket, which allows the function to read each file and in the process consolidate the data. It then uploads the new consolidated file into S3 to complete the process. These are the other user story sequence diagrams, but allow me to explain the most important in some detail. Allow me to explain the multiple run tester, which combines all of the user story functionalities into one function, and also allows batch uploads of audit files to be processed. The process is similar to the previous scenario. The IT admin requests the audit, and the audit is then put into the S3 bucket. However, in this situation, the admin would request many audits simultaneously. Each Lambda function would check the configuration file in the bucket for alert configuration information, find all of the alerts, and log them. Once the alerts have been collected, the functions publish the alert messages to the PubNub console view. The dedicated console is a polished view for displaying the alerts gathered by the multiple run tester while color coding the output based on the computer name. Next is the system design. For this project, I used a 3-tier system with presentation, logic, and data tiers. The alerts are displayed in the presentation tier, the Lambda code runs in the logic tier, and the S3 buckets and AUDIT API compose the data tier. On to the system deployment details. This project does not have any specific hardware requirements, as the Lambda code lives and runs in S3, not on your machine. In order to run the batch uploads, I use CyberDuck because it has an excellent AWS S3 upload feature. I use the IntelliJ IDEA IDE because it supports Node.js and has a plugin specifically for communicating with S3, the AWS manager. In order to write and test Node.js code, I require the Node.js interpreter. And of course, a web browser is necessary to access AWS, PubNub, or the demo page. This project does not currently store persistent data in this version. There was a plan for an additional feature that may have required persistent data, and I will mention it in the shortcomings and wishlist video. Security and privacy were not concerns for this version. The code and audit data is all stored in the AWS cloud, and only admins would have access to it. Here is the detailed class diagram for the system. This project uses a model view controller design pattern. The main control object for this project is the AUDIT API. The process is simple. The IT admin requests an audit, the API runs the audit client on the user's machine, and the client puts the file into the S3 bucket. Here I am showcasing the main algorithm for the consolidation of audit files. The IT admin interacts with the dashboard, which sends a request to the AUDIT API. The audit is run on the machine and pushed into S3. If the files are consolidated, we are done. Otherwise, the consolidate audit files Lambda function is run and uploads the new consolidated file into the S3 bucket. Because we have a consolidated file, execution terminates. All of the user stories for this project were tested by hand by creating many audit files with new data. Here is an example of a sunny day test of the consolidate audit files function. We want to ensure all audit files are consolidated in the bucket after uploading new files. First, we configure the bucket event trigger to the consolidated code. Next, we upload a new audit file into the S3 bucket, triggering the consolidation code. Now we can open the S3 bucket and check for the consolidated.json file that should have been uploaded. In this case, the consolidated file is available and has the correct formatting. Next is an example of a rainy day test of the same function. After configuring the event trigger and uploading the file, we expect to have a new consolidated file in the bucket. We open and check the bucket, but do not see a consolidated.json file. After checking the logs, we find that the function ran into a JSON parsing error when attempting to consolidate the audit files in the bucket. Regarding automated scripts, because the code is event-driven, the code runs automatically whenever an audit file is uploaded to S3. By using CyberDuck, I was able to invoke more than 10 Lambda functions simultaneously with a batch upload. Now I am proud to show you the final demo for the project. The S3 bucket is configured with the multiple run tester, and I will now upload a batch of files using CyberDuck. Within seconds, we see the alerts flowing through. Here you can see quarantines, hard disk status, firewall status, battery status, and battery level. The code sends the alerts immediately as they are collected, and the code runs asynchronously, so the out-of-order alerts are an expected result. Thank you for watching my introductory video for event-driven cloud computing.